Okay, this would be our last problem. The number of accidents that occur at a busy intersection is Poisson distributed. So this is given to us. Unlike the previous problem where we had to find out what type of probability we had, here it's given to us that it is Poisson distributed, which makes our life easier. And we're given that the mean is 3.5 per week. What's that week? In a Poisson distribution, it's very important to identify your interval. Remember, what's a Poisson? It's a kind of distribution that happens, so it measures the number of occurrences within a certain interval of time or space. Here we have an interval of time of 1 week. Okay, so this is the probability function that we're going to use, where x is the number of occurrences given the mean of the distribution mu, and here the mean is given to us 3.5, but we have to be careful. This mean is within an interval of 1 week, right? So you have to read very well what's given to you, because you need to know what to plug in this formula. This is the mean within the interval that is given to you. Okay, so here what do we have? An interval of 1 week, and mu is given as 3.5 accidents per week. Now we can answer that question easily by using the formula. No accidents in 1 week. Okay, so here also in this question that we are asked to find the probability of no accident in the same interval that was for which we are given the mean, so we can use that mean, and here we go, I put it here, and the question is no accident, so x equals 0. So now I know what to substitute in the place of x here and the mean here. Okay, so here we go, it will be 0.0302. Now part B, 5 or more accidents in 1 week. So we're still in the same interval, but now we are asking for 5 or more. So interval of 1 week, which means the mean that was given to us is still applicable, and x is, in fact, it's x greater or equal than 5. Okay, so please correct that. It's x greater or equal because it's 5 or more. Okay, how to do that? P of x greater or equal than 5 is P of 5 plus P of 6 plus P of 7 plus all the values above 5, right? But it would be too much time consuming for us to do all of these. Instead, we do the complement of these, which is that. And then we subtract that from 1. What are the complements of all these possible events? 5, 6, 7, etc. They are all the events below 5. So that's why here I have 0, 1, 2, 3, and 4. So I need to find P of 0, which we found it in part A to be equal to 0.0302. And we need to still find P of 1, P of 2, P of 3, and P of 4. That's easy. P of 1, again, mu is the same. So you see that these are not changing from compared to the one that we did in part A, but what changed is the value of x. So this changed. Now it's 1. Now it's 1 here. So that's 0.1057. P of 2, also what will change is only the x value. Now it's 2. P of 3, what changing is the x value, 0.2158. And P of 4, also here you notice. All right. And now we have all these, we add the P0 to them, which is this one, and we get a total of 0.7254. We subtract that from 1 and we get 0.2746. This will be our final answer. All right. Now the last one can be a little bit tricky. 1 accident today. What does it mean today? Remember in the previous two questions, or even the given, we were referring to a 1 week. where the mean was given per week. Now the question is today, so the interval changed from a week to 1 day, which is today, one day only. So the interval is 1/7 of the week, which means that the mean, remember in the Poisson distribution, the mean is proportional with the interval. So in the previous interval it was 1 week and the mean was 3.7. Now it's 1/7 of that, so the mean will be 3.5/7 and 0.5 accident per day. And the question is, for one accident, that means x is 1. So now I use the top formula where mu is 0.5 and x is equal to 1, and I put it there. You see, this is mu 0.5, this is mu, and my x is 1. My x is 1, and we get 0.3033. All right, so I hope that these sets of problems would reinforce your knowledge about the discrete probability distribution, and I strongly advise you to practice, practice, and practice. All right, thank you.